Okay, here we want to do is we want to look at some questions from Unit 1 on solving systems of equations. So, starting with question number 9, here is a two-variable system. We have two equations, two variables, and we're just asked to solve the equation. So on this one, again, we have our choice between elimination and substitution. Well, this one, because y is by itself, I think this is an awesome question for substitution. We know y equals 3 minus x, so what we can do is we can plug what y is in for y. So this is going to get you 3x plus 2 times this whole thing, 3 minus x, equals 12. So here we have to distribute. So this is 3x plus 6 minus 2x equals 12. Now we have nothing but x's. So 3x and 2x is x plus 6 equals 12. So then x equals, subtract the 6, and you get x equals 6. Once you know that x is equal to 6, you can plug that back in here for y. So y equals 3 minus 6. So y is equal to negative 3. Okay? So that would be solving. This is by substitution. This was solving by substitution. Okay? That's where you know what one value is and you plug it in to the second equation. On question number 10, we want to solve a two-variable system, but let's try this one using a different method. Let's use elimination on this one. Now recall, on elimination, what you're trying to do is you're trying to get two variables to look the same, like a 3x and a negative 3x, so that they can eliminate each other out when you add or subtract the equations. Well, if we notice here, we have an x in both. So here, if we were to take the second equation and multiply through by a negative 1, we would get negative x plus 2y. Oops, sorry. That's not plus 2y, is it? This is actually a minus 2y because we have to multiply all our terms. So this is minus 2y equals negative 4. So we multiplied through every one of the terms by negative 1. Now the first equation here, we're not going to do anything to. We're just going to rewrite it. Okay? And now what happens is if we were to add these equations together, x and negative x cancel out. Then negative 4y and negative 2y get you negative 6y. Okay? And then 16 plus negative 4 gets you positive 12. Divide through by negative 6, and y equals negative 2. So now we know y is negative 2. Once you know what y is, you can plug back into either equation. So let's plug into the bottom one here. So this is x plus 2 times y is now negative 2, equals 4. So this is x, 2 times negative 2 is negative 4, equals 4. So then if we add 4, x equals 8. Okay? So there's your solutions. X equals 8 and x equals negative 2. Okay? Now, looking at problem number 11, 11 says, without rearranging the term, what's the best method? So they want us to decide, should we use substitution or should we use elimination? Now, in order to make that decision, we should look at the equations here. And if we notice, doesn't look like we have a variable all by itself like we did here. It looks like we have a variable that's the same and opposite signs. So because these are the same but opposite signs, it looks like the best option here would be elimination. Okay? So elimination would be the best method to use. Okay? So number 12 says use matrices to represent the system but don't solve. So we don't want to actually come up with an answer on this one. We just want to put it in matrices. So remember, we start off with a matrix. This is going to be for your coefficients. Then we're going to have a matrix for our variables. Looks like our variables are x, y, and z. So I'm going to go ahead and put x, y, and z in here. And then that's going to equal one remaining matrix, which is going to represent your solution, not your solution, what your equations are equal to. So now this matrix, which is your coefficients, is going to be 12, 6, and -4. So this is 12, 6, and -4. Make sure you take the sign in front of it with it. Okay? So then this is 4, 2, and 5. This is 1, -15, and 12. And then over here, it's what those equations were equal to. So the first equation across equals a 15. The second one gets you -25, and the last one gets you a 16. So it says use matrices to represent the system. Don't solve. So here is your final answer for question number 12. On 13, it says, what does x equal, and what's the solution to the following system? Well, you can solve this a couple different ways. You can try to use substitution or elimination, or if you'd like, you can just use matrices. So let's just set this up as matrices, and I'll show you how to do it on the calculator. So on here, again, setting up your matrices. We've got 5, 4, and a 1. Over here, we have 0 x's, so this is 0, 2, and a 3. Then we've got -4, 4, and -2. This is x, y, and z. And then here we've got 4, -6, and 10. So if we were going to plug this into our calculator, this is going to go in the matrix A. This is going to go in the matrix B. Okay. So recall that on your calculator, matrix is right above x to -1. So second matrix. We need to scroll over to edit. And we're going to edit matrix A. It is a 3 by 3. If you don't have 3 by 3 in there, type in 3 by 3. And now fill in your numbers. 5, 4, 1. 0, 2, 3, -4, 4, -2. So there's matrix A. Then go back to matrix, second x to -1. Go to edit, this time edit matrix B. This is a 3 by 1, so make sure you enter 3 by 1. And then it's 4, -6, and 10. Okay. Now you have to go back to your home screen, and now what we want to do is we want to write the expression matrix A to the -1 power times matrix B. So go back to matrix. This time just select it from the list of names, so that's matrix A. Then hit x to the -1 key, which is the button that the matrix is on, so that gets you to the -1. And then select matrix B from the list. Again, don't go to edit, just select matrix B. Hit enter. And here is your solution, x, y, z. So here x is 0.3, y is 1.35, and z is -2.9. So what did they actually ask us? It says, what does x equal? So here your final answer, x equals 0.3. Okay? So those are the solving systems from